this is basically what we've been doing, is just changing one part of it. The A is not 1 anymore. The number in front does not equal 1. So examples like this, where the leading coefficient isn't 1 anymore. If you can divide out a GCF, that should be your first step. So if you can divide out something from all 3 terms, that's your first step. Take that out, and hopefully it'll make it into a problem where, so let's just do that example. Hopefully it'll make it into a problem where we can factor it right away. So this is one example in these 4 where we can factor out a GCF. What can you factor out of all 3 of those? 2. I'm going to divide those by 2 right away. Divide that by 2, divide that by 2, divide that by 2. If 2 comes to the outside, and divide each of those by 2, that becomes 8x, that becomes 15. Now the leading coefficient of this stuff is 1. And we're able to factor that much easier. So if you take out a GCF, do that as your first step, and then hopefully it becomes an easy problem, because you're going to see this process is not that easy. So you don't really want to have to go through this if you don't have to. What would this turn into? What can divide 15 and add to 8? That can be split into 5.3, and this can be split into 5 plus 3. So I'm going to do that. The 2 stays on the outside, and these are my 2 factors of 15, and they're going to add up to 8. So I write it as x equals 5, and x plus 3. That is my final answer. You keep the GCF on the outside. Whatever you factored out in the beginning goes to the very front, and then you're left with those 2 factors. If that doesn't work out, if you can't factor out a GCF, or if you still have a number in front of this, if this number is not 1, then you have to go through these steps. So first thing, we want to make sure we're identifying our A, B, and C. Sometimes it's not in the right order, and you're going to need to use the A and the C and the B and the C. It's a really similar idea. You're still looking for what multiplies by something and adds up to that middle term, except now we're going to use A times C. So I'm going to use the same variables I used last time. I'm thinking about 2 numbers, I'm just calling those randomly M and N, that are going to multiply to be A times C, and those same numbers that add up to be B. That part is the exact same thing as before, except now we're not looking at just C, we're looking at A times C. This is a new step. Usually this is where people get stuck. Actually, that people are usually pretty good at, and then they forget what to do with those numbers. We're going to rewrite the original expression with 4 terms by splitting the middle term into the 2 numbers that we got. The 2 numbers that we got as this M and N, that's what the middle term is going to split into. Okay? The grouping, so really what this is called is factoring by grouping. That's where this comes in. We're going to group the first 2 terms, and we're going to group the second 2 terms, and then we're going to factor each by using the GCF. These are really going to be steps that you go back to if you get lost somewhere in this. For right now, I know that this is not going to make a whole lot of sense, but when we come back to it, hopefully it'll guide you through problems that you get stuck in. The first factor is the term that's in both parentheses. You're going to see the same thing in both parentheses. It should be the same. If it's not, you did something wrong. The second binomial, the second factor, that's actually talking about the same thing. A factor and binomial here is the same thing. It's made by combining the 2 GCFs that were taken out. And you can still check your answer just like before. If you FOIL out your answer, you should work backwards to the original problem. So I kind of already told you there's no GCF in this. So if we could, we would want to factor that out, but there's nothing there. Our next thing is just identifying A, B, and C. That's A, that's B, that's C. It's just the numbers that are in front of each of these terms. So my third step is just multiplying A times C. What is that here? What's A times C there?
4.
I'm just multiplying the numbers in front, I'm not including the x squared. So it's that 4 and the negative 2. That's negative 8.
So you only use the next.
Don't use the x at all. Yep, you just use the number. Really, that's what A is talking about. It's just talking about the number that's in front. So I'm just using the 4 and negative 2. That gives me that negative 8. What's the B here?
7.
That's just the 7. Yep. This is the same thing that we were doing before. Now you're trying to figure out what's going to multiply to be that, what's going to multiply to be negative 8, and add to be the percent. What multiplies to give you negative 8 adds to be 7. You multiply those together, you get negative 8, add those together, it would give you 7. So far, we've really only tackled the first 3 steps there. The next step is the splitting part. This is going to split into those 2 numbers. That's 7x splits into 8x and negative 1x. Nothing else changes. The negative 2 stays the same, the 4x squared stays the same. Hopefully that makes sense why we're allowed to do that. These 2, if I combine those, that's 7x. I'm just splitting that. I'm really doing the opposite of combining my terms. I'm splitting that into 2 different things there. I'm not sure about that step so far. Now I'm going to factor out. Where'd that come from? That's coming from splitting this into those 2 terms. 7x is the exact same thing as 8x minus 1x. Those 2 numbers came from this. Okay. If you switch the order, I'm going to write this. You don't have to write this part. If you change the order of that, it does not change the problem at all. It doesn't change any of the next steps. It doesn't matter which order you put those in. It's the exact same thing. So I'm going to factor out, I'm basically just going to group these 2 terms. I'm going to group that and that together. I'm going to do the exact same thing with these second 2 terms. This and this. And I'm going to factor the GCF out of this group and out of this group. When you do that, you should have the exact same thing in both parentheses. What's the GCF of those 2? The greatest common factor between those 2. These 2. You're right, it's going to be negative 1 for that. But what about these 2? 4 is the biggest number. What about the x's? Yeah, I also have 2 x's here. I have 1 x there, so I can take out 1 x from each of those. That's going to come to the outside of the parentheses. 4x times whatever's left in there. 4 divided by 4 is just 1. I'm not really even going to write that. I'm taking 1x out of what was 2 x's. That leaves me with just x. Plus whatever this turns into, I canceled out the x completely. I took that 1x out to the outside, and I'm dividing 8 divided by 4. That's 2. Any questions about that first step? So I still have to factor out something from here. And actually, that's really important. What I have to factor out has to turn it into this exact same thing. This will turn into that. I always just start by writing that. I know once I factor something out of here, it has to turn into this. It has to be the same thing in the other parentheses. What does that have to do? I'm factoring out a -1 from there, and a -1 from there. That comes to the outside. If you can't really factor anything out of there, and you think it's just a positive one, you still want to write that. You want to write the +1 there, because that sign and number are going to be really important there. The two factors that you end up with are whatever's in the parentheses, x + 2, and the two GCFs that you pulled out of these sets of parentheses. This 4x and this -1 makes up the second factor. So 4x minus 1 and x + 2 are the two factors. That is the final answer. That's factored as like this.
So you basically just.
You're supposed to be confused. It's not a straightforward process. There's a lot of steps. Let's go through a couple more examples and it's supposed to be confusing at first. Do you have any specific questions about where certain numbers came from?
I don't understand how you got the 4x minus 1.
That's coming from the two GCFs. That's the 4x minus 1. The stuff that's in both of these parentheses is the other factor. X + 2, 4x minus 1.
So the 4x and the -1 don't go in the second.
It could. You could reorder this if you wanted to do x + 2 and 4x minus 1. That's the exact same thing. The order of the factors doesn't matter.
It's just not going into the x + 2.
The -1.
Yeah.
Yeah, that was taken out of this x + 2.
And then it transfers it together.
Yep. Actually, let's show why that makes sense. When we're foiling something, basically it's just distributing both of these into this set of parentheses. It's taking that 4x and distributing it into here. That's exactly what's doing. 4x gets multiplied by both of these. The exact same thing happens with this -1. The -1 gets distributed in here, and that's exactly what's happening here. That's why we can factor it out and make it into one thing. Those come together. Basically, it's reversing that distributing process that we would be doing going forward. Problems will make more sense after we do a couple more examples. What is A times C on number 3? What's AC there? I'm not sure. What does that give us? What does that give us, though? What's A times C? Yeah. That's 40. Caleb, what's B there? So Jackson, what's going to multiply to be 40 and add to be -14?
-10.
Yeah. -10 and -4. Those multiply to give us that, and they add up. Give us that. That's how we're going to split this -14. That's going to split into two different terms, -10 and -4. Yep. -10x and -4x. Actually, it's doing basically the opposite of a bunch of stuff that we've learned this year. It's doing the opposite of combining like terms in that step, and then the next step, it's doing basically the opposite of distributing, and then the opposite of foiling. We're working backwards in those three processes. I'm going to group these first two terms. 5x squared and 10x, or -10x. What can I factor out of both of those there, and what can come out of both of these? 5x comes to the outside of that. We divide that by 5x. That leaves us with just x. Divide that by 5x, the x's cancel out. and we're left with just negative 2. Now I'm going to group these. What can I factor out of both of those two? Or what can I divide that by and that by to get it to be the exact same thing as this one? I would especially look at the numbers, going from 8 to negative 2. What do we have to divide by? It's got to be a negative. If he's going to change signs, it would have to be a negative. Any questions on what we've done so far there? What are my 2 factors? How do I put that together to make 2 factors? 5x minus 4. That's coming from this and this. That's one of my factors. The other one is whatever's in the parentheses, the x minus 2. That's it. That's your answer. You want to check it. Actually, if this is a multiple choice question, I might not do that. If there's answers there, I might FOIL those out and see which one would give you that. But you can always check your answer that way, at least. FOIL that back out. 5x times x, 5x squared. Negative 4 times x is negative 4x. Negative 2. Negative 2 times 5x is negative 10x. And then negative 4. And negative 2 gives us positive 8. You combine those like terms and you get that negative 14x.
So they give you.
I'd work backwards. Yeah. Why is it? Oh, because there's 2 of them. That's a good point. Really, it's because we took out 2 questions. Because we took a 5x out of this one and a negative 4 out of this one. When we FOIL, we're actually using it twice. So here, like when we FOIL, we're doing this times everything in there, and this thing times everything in there. So we're really still using this twice. It just shows up twice here because we're using it once with the 5x and once with that negative 4. It's not that we're actually multiplying this whole thing times that twice. We're multiplying this times it once and this times it once. What is AC on this one? Yeah, that's, we got supposed to be there. So, I have AC, I have B. What's going to multiply to give me a positive 20 and add to give me a positive 9? That's going to split into 5x plus 4x. Nothing else changes at all. Find whatever multiplies to give you AC and adds to give you B, and this middle term splits into those 2. So what do I do next? So I group my first 2. What can come out of there? So what can I factor out of both of those? Actually, we can't divide that by 2. We actually can't divide anything into both of the numbers. How many x's can I pull out of both of those? 1. So I'm really just going to divide by x. There's no number that comes out of both of those. So I'm just dividing by x. X comes to the outside. 2x is left for my first term, and 5 is left for my second term. And I'm just going to start out by writing the second set of parentheses because I know what it has to turn into. I know it has to be the exact same thing as this. What can I divide these 2 by to get it to look the same?
2.
5 should be the easy one to identify. It's already in parentheses there. This will take some practice to get in the habit of doing on your own, but let's start making a little more sense. Any questions before you practice a little bit on your own? Actually, I want to show the first step of one other problem. Go to the back of these notes. There's practice problems on the back of that one. And look at number 6. So the first thing I want to do there is find if I can factor out something from all 3 of those. What can I take out of all of those? 2 is good. What else? Yep. There's an x to the 4th here, x to the 3rd there, x squared there, so I can factor out 2x squared from each of those. That would give me 2x squared on the outside of the parentheses, and then 3x squared plus 2x minus 8. So really, that was just taking the GCS out. This is now one of the problems that we just did. So you're going to take this and now factor it just like we just did. When you get a final answer, it's going to look like this. Whatever factors you get from this, here, the GCS just stays out in front. Finish that problem. Then do numbers 10 and 11. All right, so you're going to do 6, 10, and 11. All right, so from here, all I did so far was take out the greatest common factor, and I just know it's going to end up on my final answer. I don't really write that the whole way down. I don't write that with my solving process here. Otherwise, you might get confused. Really, I just think about that as a whole new problem. I'm trying to factor that. I'm thinking about a times c, a times c as negative 24, and b as 2. So this has to split into, you can write either one first. I'm going to write that negative 4 first. Negative 4x plus 6x minus 8. Minus 8, 3x squared, those didn't change. I really just split that into the 2 numbers that multiply to give me that, and give me this. Then I'm looking for the greatest common factor between those two. There's no number that divides those, so it's just going to be an x. X divides 3x squared, makes that to 3x. X divides this, makes that into just negative 4. Then this needs to be the exact same thing, 3x minus 4. And to get that to happen, this needs to be divided by 2, and so does that. And it's a positive 2, so I'll write it as a plus 2. Sign is important because I'm going to use that with this x. X plus 2, and 3x minus 3. That's as factored as that gets. Make sure you write the greatest common factor on the outside of that, because you have that, and that has 3 factors really of this thing. Nope, it does not. You can write this. Really, if you wanted to, you could write 3x minus 4 times x plus 2 times 2x squared. You can completely flip the order. It's the exact same thing. Multiplying means we can multiply, or meter property means we can multiply in any order. All right. Jackson, Cameron, you're up. Choose whatever color you want. I got it. Yep. Explain loud enough for the computer and your students to hear you.
So for the first part, you have to do the A let's see, you have to multiply these two, so you get 20 over here, and 9 over here. And then you have to figure out what goes in 20 and 9, which would be 24. And those would substitute for that. And it would be n x plus 5 x plus 4 and then after that, we have to put them in the groups. So this will be group number 1, and this will be group number 2. Then you have to figure out what to divide them by. So for the first one, we would divide by 5x on this side. We would get 2x plus 1. So this side has to equal 2x. So we divide by 2. And then this would give you 2x plus 1. And we divide by 5 over here and 2 over here. We put 5 goes to the first parenthesis, 5 back. 5.
Show what you're missing on that bottom line. What are you missing on this line? Why'd you put the 2x plus 1 in parentheses on the left side? Like, what came to the outside of that?
5x.
Yeah, show that. And do the same thing for the second one.
So then 5x and then plus 1 plus 2 for your first parenthesis. And then your second parenthesis, which will be this number right here. So it would be 2x.
Good. Good. And then that's the right one. Where the zero?
So you like do 8 times C. You do 8x squared minus 4x. Minus 2. And you divide by 4x to 8x squared negative 4x. And then you get 4x outside the parentheses and then 2x inside minus 1. Get 3 outside parentheses. Put 2x inside minus 3. Start to explain it yourself.
Where those come from? Where the 4x plus 3 come from? To show that.
write it.
Okay. Flip that paper over.
No, you should.
These are really the special cases of what we've been doing. If you're comfortable doing everything that we just did, the factoring by grouping, this works on all of these as long as you recognize what's actually happening there. But there's way easier, quicker ways to do this, so we don't have to do that every time. There's a faster way to do this that you don't have to go into all of that. If A and C, actually I hate the way this is written, it's not A plus C, it's A and C. If those are perfect squares, basically if you can take the square root of those and you get a nice full number, then you might be able to use it. So first, we're really just going to take the square root of the first and the last terms. So we're going to take the square root of that whole first term and the square root of the last term. Really, that's all we need to do. That's going to make both of our factors. What's the square root of that top one? 4x squared. What's the square root of that? What's the square root of this? 2 and a little bit more.
X.
We're taking the square root of x squared. That just turns into x. So the square root of 4 is the 2. The square root of x squared is just x. That's the square root of 25. That's really all we need to do. We put those two together. 2x plus 5 squared. It's just those two as the factor, 2x plus 5. And it's the same factor twice. If you were to do this by grouping, you would find that it's 2x plus 5 and 2x plus 5. When you write that, you really want to write it like this. That's the simplest way that you can write the same factor twice. 2x plus 5, 2x plus 5, it's the same thing twice, so it's just 2x plus 5 squared. It's a lot faster than having to go through that whole factor by grouping. This one's kind of the same, except the sign's going to be different. That's going to come from multiplying this out. 2x times 5 and 2x times 5. Those both give us 10x. 10x plus 10x gives us that another 10x. This is kind of the same thing. This is a perfect square, 9m squared. And so is 64. So we're going to the square root of 9m squared and the square root of 64. What's the square root of 9m squared? 3m, and the square root of 64, 8. Those two together make our whole factor. It's just going to be the same thing twice because it's a perfect square. Why did I choose to write a negative sign in between them? It's got to be a negative to make this sum of negative 48. I'm going to multiply, I'm going to write that out, 3m minus 8 times 3m minus 8. If I multiply negative 8 times 3m and negative 8 times 3m, to get a negative 48 as the sum, that would have to be negative. But when I multiply negative 8 times negative 8, it still gives me a positive 64, so it doesn't change that far.
It's not maybe wrong, but like, if you have an exponent in mathematical language, it only contradicts itself.
Kind of, if it's a 2, then yeah, it completely does. Or if it's like the cube root of m to the third, that just cancels out. Yeah, that's just m. So we're going to figure out what the sign should be. Oops. figure out what the sign should be based on whatever the sign is in that middle term. That tells us the sign in the middle of our factors. Any questions on that? That's a lot easier than having to do the whole thing. As long as you recognize that they are perfect squares, if you do that. If you feel comfortable factoring by grouping, then that will always work and it'll still give you the exact same thing. Same thing applies on this one. This one's much easier to recognize though. That doesn't have a middle term. Whenever that happens, that means the x is canceled out. The two x terms that were in the middle canceled out and gave us nothing. It's still the exact same thing. A and C are still perfect squares. But now there is no B. The B's completely canceled out because one was positive, one was negative, and it ended up with 0. So again, if you wanted to do factoring by grouping, you would just think of the middle term as 0. But we don't really have to do that. It's the same exact process as before. Do the square root of the first one, square root of the second one. But the signs we don't really have to debate about here. What's this going to be? Square root of 9x squared. 3x. Square root of 16 is 4. The signs are always going to be the same on this type of problem. 3x minus 4 and 3x plus 4. There needs to be one minus sign and one plus sign because they ended up canceling out to make this 0x. There's going to be one minus sign and one plus sign. If you are comfortable doing it that way, you can. If you want to do the factoring by grouping where you do A times C, you get 784, really negative 784, and B here is 0, you can still use that to solve that. It's just a lot quicker. If you recognize that there is no B term, that's a lot easier. What is this one going to turn into? Let's give me the two factors where it's...
7 minus 5 plus.
Yep. You don't have to do that whole thing. You recognize that that's perfect square, there is no B term, and that's perfect square, then you can immediately do that. So square root of this, and the square root of that with opposite sides. It also allows us to do a little bit of trickier problems with two different variables. This is the exact same thing. When there is no middle term, it's still the exact same thing. 16x squared and 49y squared. What's the square root of that? That's what the second one? That one has a y. It's the exact same thing. The middle terms cancel. So this is going to be 4x minus 7y times 4x plus 7y. And what about letter D? What's that going to turn into? What are the two factors there? One's going to be minus, and one's going to be plus. That's a lot easier than having to do factors by grouping. But again, you can always rely on factors by grouping. That works on any single problem. If A is 1, it'll still work. So on the back of this, your first problem, A is 1. If you don't happen to see that, you can still use the factor by grouping. Now you're going to finish these problems.